Hi, it's Double O Pi, your undercover chemist here. Today we're going to talk about isotopes. Let's start out by doing a quick review of what we call nucleons. Nucleons are subatomic particles that are found in the nucleus. And there are two sorts of nucleons. The first sort of nucleon is called a proton. Protons are positively charged particles. More importantly, the number of protons that are found in the nucleus of an atom helps to determine the chemical properties of that atom. And so every element is made up of atoms with a specific number of protons. Now, in the nucleus, in addition to protons, there are also neutrons. Neutrons are particles that have no charge, and they do not affect the chemical properties of the element. They do affect physical properties of that particular atom. The more neutrons you have, the heavier the nucleus is going to become. The reason we have to understand the difference between protons and neutrons is that you can have atoms that have the same number of protons but different numbers of neutrons. For example, you can have 3 atoms of carbon. Carbon has 6 protons. So you can have one atom made up of what we call carbon-12, which has 6 protons and 6 neutrons, for a total of 12 nucleons. That's why we call it carbon-12. You can have an atom which has 6 protons, keeping it carbon, but 7 neutrons. That's 13 total nucleons, giving us carbon-13. You can also have an atom of carbon with 8 neutrons, and of course 6 protons because it's carbon. That would be carbon-14 because it has 14 total nucleons. So because you can have these atoms which have the same number of protons, which we refer to as having the same atomic number, but they have what we call a different mass number, the sum of the protons and neutrons. Basically, the mass of the nucleus is different because of the different number of neutrons. These are slightly different from each other in mass, and we call these atoms that have similar atomic numbers and different mass numbers, we call those isotopes. So what we're going to learn in the rest of this video is how chemists and also physicists represent different isotopes of a particular element. And we have a specific way of writing things. For example, here is the symbol for helium-4. So you can see this is composed of 3 different parts. First we have a group of letters. Here that group of letters is He, and that is the symbol for the element that we're talking about. So if you look at helium on the periodic table, you can see, if we zoom in just a bit, that the name helium is in small letters, and then the symbol for the element helium is above it in large letters, He. So that's where we're going to get the symbol for the element, is from the periodic table. Now the second thing in this isotope symbol is a number. This particular number, which is found to the lower left of the element symbol, is what we call the atomic number. Sometimes the atomic number is abbreviated with the letter capital Z, and basically what that is the number of protons that are found in the nucleus. How do you know how many protons are found in the nucleus? Remember, the number of protons in the nucleus determines the chemical properties of an element. And so that number of protons is always the same for a given element. So looking back at the part of the periodic table that describes helium, we see that up in the upper left corner we have our atomic number. There's the number 2. And that will always be the number of protons in that element. Now there's a second number here, the third part of our isotope symbol, and that's a number which you can see is larger than the number in the lower left. This is what we call the mass number. And sometimes instead of writing out the words mass number, we will use the abbreviation capital A. Basically what this is the number of nucleons that affect the mass of the nucleus, which happens to be the number of protons and the number of neutrons combined. So for this isotope of helium, the total number of nucleons is 4. Now we know that 2 of those are protons, and that means the remainder of them must be neutrons. So this is an isotope of helium that has 2 protons and 2 neutrons. Now, if you are asked to write a symbol for an isotope, it's fairly simple to do. There are 4 very simple steps. First of all, find the element symbol. Second, find the number of protons it has and write this to the lower left of that element symbol. Third, find the number of neutrons it has. And fourth, find the mass number by adding the number of protons from part 2 and the number of neutrons from part 3. And then you can write that number to the upper left of the element symbol. Let's do a couple of examples. First of all, let's say you were asked to write the correct symbol for an isotope of krypton that has 46 neutrons. So the first thing we need to do is find the element symbol for krypton, and to do that, we're going to go to the periodic table. Here's the periodic table. Let's look for the element krypton. Oh, look, there it is right there in the noble gases, group 8A. Okay, let's zoom in on that in case you can't see the small writing on the screen. Here's what we've got. Okay, do you see the element symbol? Here it is, right here, Kr. So we've got our element symbol, and we're going to write that. That's always the starting point, because the numbers that we write next have to be written in relation to the element symbol. The second step is to find the number of protons this isotope has and write it to the lower left of the element symbol. Where do we find the number of protons? Once again, let's go to the periodic table. Remember where to find the number of protons? The atomic number. It's up there in the upper left. So that's 36 protons for krypton. And so let's take that number, 36, and we're going to write it to the lower left of the element symbol right here. Now we need to find the number of neutrons it has. Well, that's easy. The problem gives us that. It says we have 46 neutrons. So let's take the number of neutrons, and we're going to use that to find its mass number. So the mass number, if you remember, is the sum of how many protons there are and how many neutrons there are. So we had 36, that's how many protons we have, plus 46, which is how many neutrons we have, and that gives us a total mass number of 82. And so now we can write that number right here. So here is our correct isotope symbol for an isotope of krypton that has 46 neutrons. Let's go ahead and do another one of these problems that's slightly different. Write the symbol for an isotope that has 29 neutrons and 24 protons. Now here it's giving us the numbers of protons and neutrons right away, but there's one thing it isn't giving us. Do you know what it is? Step 1, find the element symbol. How are we going to do that? Well, we know how many protons it has. We know the atomic number. So let's go to the periodic table and find something that has 24 protons, whose atomic number is 24. Scan across the periodic table and look. Hey, look what we've got right here. Chromium. Chromium is element number 24. It has 24 protons. Here we go. Chromium, and the element symbol for chromium is Cr. Let's write that and move on to step 2. Step 2 says find the number of protons it has and write this to the lower left. Again, we were given that number in the problem, 24 protons. Number 3, find the number of neutrons that the isotope has. And again, we're given that. That's easy, 29 neutrons. Let's use that in step 4 to find the mass number for this isotope. We're going to add the number of protons, 24, and the number of neutrons, 29, and so that will give us a total of 53 for our mass number. And then we could take that mass number and put it in the upper left of the element symbol. There we go. So now you could see that our isotope symbol for an isotope that has 29 neutrons and 24 protons looks like this. Thank you for watching. Please check out the other problem-solving videos from the Double O Pi Productions YouTube channel.